Hello, let us introduce our research model of the recommender system for the selection of electronic learning resources. In our research, recommender systems are a class of intelligent systems that generate recommendations on fuzzy logic methods by forming a rated list of electronic learning resources that meet certain requirements and criteria. The aim of the article is to model and develop the recommender system based on fuzzy logic methods for expert evaluation of learning resources that allows us to choose the most effective ELR for use in the learning process on the basis of generated recommendations. The development of a recommender system for evaluating and selecting electronic learning resources aims to make the selection of alternatives process fast, accurate and correct. Creating a conceptual model of the recommendation system allows to identify its different components and possible ways of their interaction. Conceptual model developing of the recommender system ensures the identification of its different entities and their potential interaction. Identifying these requirements at this stage allows to save resources in subsequent stages of the development life cycle when adding new components of the recommendation system requires more effort and resources. For describing the functions of the recommender system, the use case diagram, which shows the interaction between the user and recommender system, the relationship between the user and various use cases in which the user is involved, has been developed. This diagram shows the sequence diagram of the recommender system for selecting electronic learning resources. The next one shows an activity diagram that visualizes the process of use and illustrates the flow of messages from one action to another. It demonstrates the holistic operation of the system. The main purpose of an activity diagram is to show the order of execution or sequence of actions. The approach using fuzzy logic is a fuzzy extension of the analytic hierarchy process methods, which is one of the most commonly used methods for solving decision-making problems with multiple criteria. The 8P method breaks down the problem and uses pairwise comparison of all elements and compares criteria or alternatives with respect to the criterion in natural pairwise mode. The process begins with collecting quantitative and qualitative data as well as linguistic decisions from decision-making experts. Then the necessary calculations are performed using fuzzy logic methods. In the construction of the membership function using the second method, for each pair of elements in the universal set, an expert assesses the advantages of one element over the other regarding the properties of the fuzzy set. Such pairwise comparisons can be conveniently represented by the following matrix. You can see matrix A, where items A Ij is the level of preference of the element Ui over Uj that is determined by the 9.30 scale. The pairwise comparison matrix is diagonal and inversely symmetric. Here you can see the procedure for applying the fuzzy logic methods with formulas denoted by 1 till 3. It's continuous. For example of decision-making in fuzzy conditions using the Bellman-Zadeh scheme will be considered comparison of for computer mathematics systems, GeoGebra, SMS Studio, SageMath, Wolfram Mathematica, for effective use in the mathematical training of IT specialists. For evaluating the computer mathematics system, we will use the following criteria from G1 to G10. The expert conclusions correspond to the following pairwise comparison matrices. You can see them here. Each matrix has 6 elements that correspond to pairwise comparison from the table. Other elements are found taking into account that the pairwise comparison matrix is diagonal and inversely symmetric. Applying formulas from 1 till 3 to the pairwise comparison matrices, we obtain the following fuzzy sets G tilde 1 till 10. According to the fuzzy set, CMS P1 is better according to the criteria G1, G2, G4, G5, G6 till G10. CMS P4 according to criteria G1 till G6, G9, G10. Therefore, the choice of CMS will depend on the importance of the criteria. To calculate the coefficients of relative importance of criteria, we will use the expert pairwise comparison method. The following pairwise comparison matrix corresponds to expert judgments. You can see them here. Using formulas 1 and 4, we can calculate the coefficients of relative importance of criteria. That means the highest importance for decision making is given to functionality G7, the number of topics for processing G8, and relevance to the subject area G9. Using formula 6, we obtain the following fuzzy set. You can see them here. The intersection of these fuzzy sets gives the following degrees of membership for the fuzzy decision D tilde. As a result, we obtain in a fuzzy set D tilde, which indicates the superiority of CMS P1, which indicates the superiority of CMS P1 over others. So CMS P1 is better than the others, which similarly satisfy all criteria taking into account their importance. Fuzzy sets that show how fully the CMS P1 to P4 meets the criteria G1 to G10 are written as follows: P tilde 1 to P tilde 4. The recommended CMS according to criteria G1 to G10 is shown in the next figure. This CMS was obtained by calculating the unfilled area of a cycle, that is, the part of the LR quality that still needs to be achieved for its 100% completeness. Based on the conducted research, a list of recommended CMS has been obtained in the following sequence: GeoGebra, Wolfram Mathematica, Math Studio, Sage Math. According to the research, the recommender system will suggest alternative CMS in such sequence that corresponds to the criteria mentioned above. The main task of the recommender system is provide personalized recommendations to the user, taking into account their preferences while choosing electronic learning resources. Thanks for your attention.